That is the summary that I have up to now. So go back to the previous lecture. If you remember, we have already calculated the value of C tilde 1, C tilde 2, up to C tilde 8. All right? And at that time, we say the value of C tilde 1 is equal to this much. That is a complex number right there. So as you can see, that value of the complex number C tilde 1 we already calculated earlier. The first part, that gives you the value of the real value corresponding to the complex number. The second part, which is this term right here, 1/2, give you the imaginary number. So based on that, we can easily express the same complex number in polar coordinate. How? Well, by computing the amplitude A. And the amplitude A, as I told you earlier, is equal to the square root of the real part square plus the imaginary part square. So for this particular case, if you plug in the value for the real and the imaginary part, the value of A is equal to 0.5927. So that is the amplitude. The next thing is, how do we calculate the angle theta is equal to what? All right. Well, based on the value of R and I, we can see the value of theta is equal to 2.1377 radian. As I explained to you, as I showed to you in right there. Now, I have to explain to you more carefully how do we calculate this value of theta, because this could be a little bit confusing. But keep in mind the fact that for that complex number C tilde 1, the real part R is negative, whereas the imaginary part I is positive. It is important to recognize that, okay? So let's see the next slide. Now, remember the angle theta, you can compute, you can do it either way. You can compute the angle theta based on this formula, which is cos of theta is equal to RK over A. Now, obviously, the value of RK you already know, and the value of the amplitude A you already know, as I told you on the previous slides. See, the value of the real part is -1 over pi, and the value of the amplitude A is 0.59. So knowing the real part and the amplitude, we can use the formula right there to calculate the angle theta. And when you do that, you will see that the value for theta will be equal to 2.138 radian, which is the same thing as 122.48 degrees. However, if you calculate the angle theta by using a different formula, like sine of theta is equal to IK over A. Now, obviously, you know the imaginary part component, and you know the amplitude as well, based on the previous slide. You see, the imaginary part is equal to plus 1/2, and the amplitude A is equal to 0.59. So you can also find out the angle theta based on the second formula, which is sine of theta is equal to this. Well, if you use this formula, then the answer you got for theta will be equal to 1.004 radian, which is the same thing as 57.52 degrees. So the problem is, how do you know which answer is correct? Because if you use the first formula, your answer for theta is 2.138 radian, which is 122 degree. When you use the second formula, the answer for theta is 1.004 radian, which is 57.2 degree. So is this the correct answer for theta, or this is the correct answer for theta? Well, in order to see which one is right or which one is wrong, you have to remember what I said to you earlier. And what is that? The real part of C theta 1 supposed to be negative. The imaginary part for C theta 1 supposed to be positive. Okay? Real part is negative. Imaginary part, positive. So let's see. Let me try to draw a picture here. In order for to have, let me go back again to see. The real part supposed to be negative, as you can see, and the imaginary part is positive, okay? Real part is negative. All right. So in order to have the real part equal to negative and the imaginary part equal to positive, that complex number should be right here. Because at that point, you can see clearly the real part will have a negative value, and the imaginary part will have a positive value. So the complex number must be right there. And if that location is right there, it means the angle theta has to be somewhere between 90 degree and 180 degree. It has to be somewhere between 90 and 180 degree. Therefore, this is okay. This answer is okay. 122 degree is somewhere between 90 and 180. Whereas the second answer, you got 57.52, this answer cannot be accepted. So based on that, we conclude that for the complex number C theta 1, instead of expressed in terms of the Cartesian coordinate is minus 1 over pi plus 1/2 of I, we can express that as the amplitude A, which is equal to 0.59 times E raised to the power I times theta. And the value of theta is equal to 2.1377 radian. Now, this corresponding to one point related to figure 1a that I told you earlier, that I said I'm supposed to explain to you figure 1a and figure 1b. And then similarly, we can do the same thing for the next number, C theta 2. We calculate earlier, we know C theta 2 equal to 0 plus 1/4 of I. If you express that in terms of the rectangular Cartesian coordinate, in a similar way, that complex number C theta 2 can be expressed as the amplitude A, which is equal to 0.25 times E raised to the power I theta, where theta in this case is equal to pi over 2. And pi over 2 is the same thing as 1.57 radian. Okay? So and so on, you can express the next complex number C theta 3 in terms of the polar coordinate by computing the amplitude A, which is in this case 0.17, and the angle theta, which is 1.7799. And we can do all the way until C theta 4, C theta 5, C theta 6, C theta 7, and C theta 8. And that is the end of this lecture. And this is the acknowledgement.